Okay, welcome to this video on digital electronics. This is the introduction on what digital electronics is. Okay, so for this, once again, it's going to be a very quick and fast sort of revision-like video for you to know what are the important points. So I'm not going to go through in great detail. I'm just going to be very targeted at what you need to know. Okay, so what is the difference between analog and digital signals? So analog signals go in a wide range of values. So this is what analog signal is. It can go very high, it can go very low, it can go here negative, medium, very low, medium, very high, so on and so forth. So there's a wide range of values you can expect from an analog signal. But a digital signal is only zeros and ones. Okay, 0 volts, 5 volts. Logic 0, logic 1. So that is the difference between analog and digital. Okay, so analog, wide range of values, can be anything. Digital, you're only working with two, zeros and ones. Alright, so that's all you need to know. Next thing, logic switch. So what is the purpose of a logic switch? A logic switch is to ensure that the output here, the output is a logic 0 or it is a logic 1. That's all you need to know. We have logic switches. These resistors are placed here to pull up the value when the switch is open. So when a switch is open, I don't want a floating value up here, right? When a switch is open, by right it should be a 5, but you never know. It might be floating. I don't know what it's going to do. So this resistor is to pull up the value when the switch is open to make sure that the logic is 1. And when you close the switch, it's going to give you a logic 0. That's all you need to know about what a logic switch does. It ensures that the output is either a logic 0 or a logic 1. So what happens if I want a logic 0 when the switch is open? Because sometimes you might want that in your circuit design. That is where we have a pull down resistor. So when the switch is open, now the output is a confirmed 0 value. And when I close the switch, it's going to be logic 1. So what you need to know is you need to know how to draw these two. You need to know when I have a pull-up resistor, switch close, it gives me a 0, switch open, it gives me a 1. When I have a pull-down resistor, switch close, it gives me a 1, switch open, it gives me a 0. Remember this. And the whole reason why we have these pull-up and pull-down resistors is that we do not want a floating output. This is bad. So if I do not have a resistor, this fella might be floating. And when you do your projects, your circuit builds, this will mess up your inputs and outputs to your next subsystem. So this is not what we want. Okay, always use a pull-up or pull-down resistor whenever you need to ensure you have a digital output or input. Okay, so so what are the advantages and disadvantages? So it might seem like, wow, why don't we all work in digital signals, right? The problem is that the world we live in gives us mainly analog signals. You think about it, the volume right now, the volume that I'm speaking with is not a consistent volume or not talking. I can vary my pitch, my tone, my volume. So that's an analog signal. Light, it doesn't go from dark to light at once, right? There's a whole range of light values. So so that's why we still need analog to digital converters and vice versa. Now, what you do need to know is that there are advantages of digital signals. Go remember the first one. Okay, they are less affected by electrical interference. Okay, and even if they are, what we can do is that we can restore the signal. So that's the second advantage. Because all we need to know is above a certain value, I know it's a high. Below a certain value, I know it's a low. So I can restore it to a high, low, high, low. Okay. The third advantage is that it's generally easier to design systems when we only need to consider a high, low value, zeros or ones, 5 volts, 0 volts. And it is also easier to store the information. And this is where computers use digital signals to store information, zeros and ones. right? And because of this, larger components can be squeezed onto one semiconductor material. So your CPUs, your GPUs, all that, they're getting more and more dense with more and more transistors and whatnot, simply because all it needs to work with is zeros and ones, on, off, 0 volt, 5 volts. And this will eventually reduce costs. However, they do have disadvantages, okay? It can only process digital signals, but many quantities in our lives, like I said earlier, are analog quantities, okay? So you need to convert these analog into digital, and then for us to hear it or see it or feel it, you need to convert it back into digital to analog. So there is an additional conversion process, but I feel it's worth it. So just a quick one, remember all the advantages, the 5 advantages, and remember the disadvantage. Now, I want you to go and replay this video before I go on to the next part of the video series on introduction to digital electronics. Okay, so make sure you know very well what we've been talking about before you watch the second video. Okay, so see you in a while.